Okay, so like I was just saying, we're really going to talk about specifics of linear functions. And the first thing that we're going to talk about is slope. Okay? Now, yep, you have a question? Or you want to, no? Okay, so you've heard the saying, hit the slopes, okay? That is what it means, okay? What is the most boring slope possible? More boring than that. Flat. And that has a slope of 0. Okay? So, just so you know, just to get yourself some bearings, this has a slope of 0. Oh, I should write slope 0. Okay, a 45 degree is actually slope 1. And this has a slope of infinity, or undefined. Okay, that is one difficult slope to be skiing down. Actually, and I want to put one more on. I want to do this one, because that is slope -1. Okay? So that helps you get your bearings, right? That you're kind of understanding some stuff about just the and you know, 45 degrees, as you'll see, the rise, the run, right, would be the same. Therefore, rise divided by run should equal 1. Yes, shut. That's infinity. So it's like an 8, kind of laying down, lazy 8. Got blown over in the wind. Okay, now, so slope equals rise over run, always, which is delta y over delta x. What does delta mean? Delta means change in. Okay, use a lot in physics formulas. Okay, so that's the change in y divided by the change in x. Now, the way you do slope is by drawing triangles. Okay, so let's talk about, I'm going to talk about slope AB. Now, y equals mx plus b, remember that from yesterday? M means slope, okay? That's something you're going to have to wrap your head around. Don't ask me why, okay? I should Google that someday. Why does m equal slope? But s was taken for seconds, right? Got that one first. So you can't have having variables having different meanings, okay? Not for standardization. So m always means slope. So when I find the m of AB, now you want to do a triangle from A to B. So from A, I would come up here, and I would go like that. Okay? Do you see how I've done a triangle from A to B? Now, what is the rise? Two is the rise. Now, what is the run? 1, 2, 3, 4, 5. How much? 6. So 2 divided by 6 is the, and you will always reduce your fractions, and that becomes 1/3. The slope of AB is 1/3. And because it's going up from A to B, it will be positive. One's going down will always be negative. Okay, so just remember, M up is always positive, M down is always negative. Yes?
What about doing it the way that you did in science class, where it's y2 minus y1 over x?
Yeah, and we'll do some of those as well. Okay?
Presumably.
So you've already, oh, how many people take science in here? Just 2? Okay. Yeah, and I don't know if I'm going to get into that till next unit. Yeah, I'm going to do that next unit, get really specific with that stuff. So it's just an introduction today. But if you're used to slope, it's good. Okay, let's do MCD. Okay, again, a very efficient way of saying find the slope of CD. That's what MCD means, right? So you're just translating here, okay, from math to English. Now, CD, we're going to go down and to the right. So if you go down from C, we went down -3. So it's -3. So if you'll always go up and to the right, or down and to the right. I think I said left, but so always go up right or down right. Never go left. Okay, and you'll see it'll always work. Okay, so it is -3 and 5 here. So -3/5 is the slope of CD. Okay, now let's do EF. So the M of EF, what is the rise? No. Okay. Yeah, we can go -4. What is the run? What is anything divided by 0? Can't divide by 0, so that's undefined. Remember I told you a slope? Okay, that's infinite slope. If you've ever skied anything like that, that is scary stuff. Okay? Even if you ski like a 30 degree, it feels like you're not even touching the snow as you're going down. Things are pretty tense when you're doing something like that. Okay? Now, let's look at M of GH. Okay? What is the rise? 0. What is the run? 5. What is 0 divided by 5? 0. Okay? And I told you flat is 0. Okay? So slope is infinity. I'm just going to, or you can write this up top, undefined. Okay? Okay? So if it's positive, then the line segment rises to the right. Okay? So if you start here, do you see how it rises to the right? If it's negative, then it falls to the right. So you would have this. If it's 0, then the line segment is horizontal. If it's undefined, then the line segment is vertical. Okay, so all linear graphs will always have a slope. And when you get to Math 31, you'll find that even something like this always has a slope. It's just always changing. The slope is very different in every different part of the graph. And Newton came up with a really clever way of being able to find the slope at every single point on that curve. No, I'm not going to give away the ending. You'll have to get there yourself. Maybe we'll see you there. Okay, this is not working. I do not know why. Okay, now here's some words that you never know, might show up on a unit exam. The word interpolate means to obtain data between given data points. Okay, so if you had a graph and you had this point, this point, this point, this point, and you like joined the lines, if you find any information right there in between the points, that almost looks like it's going to be very, okay, that's called interpolation. That's finding information within 2 points, okay? Because there is about 60 gazillion points in between those two, so there's lots of data to be found. Now, extrapolate is when you obtain data beyond given points. Okay, so if you had a graph and it went like this, 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 and it stopped there. Okay, well, we're going to say, hey, I see a pattern. So I'm going to find data beyond my points. Extra, right? Extra. The other one, in the points, extra the points. Okay, that's where it gets its roots from. A horizontal intercept, or the X-intercept, is the X value. Doesn't look like value, does it? Value where the graph crosses the x-axis. Okay, and I'm going to give you the vertical one, and then I'm going to draw a picture. The vertical intercept, we never call it the vertical intercept, the horizontal intercept, just so you know. I've never, right? I always call them the x-intercept or the y-intercept, but it is the y value for where the graph crosses the y-axis. So if we draw a graph here, and there's my graph, that is the x-intercept, that is the y-intercept. Why? Because that's the y-axis, and that's the x-axis. Put little arrows on my line here. Okay, nothing too earth-shattering at this point, I'm sure, but helps us all be on the same page. So when I use that vocabulary, you're like, what are you talking about? Some of you guys might say that anyway after we've done it. Okay, so float planes fly into remote lakes in Canada's northeast wilderness areas for ecotourism. The graph shows the height of a plane above a lake as a plane descends to land. Okay, so they start the clock, and at 0 time it's 1,000, and after 10 minutes it is on the ground, right? Because 0 height, we would assume it's on the ground. That makes sense? Okay, now what is the y-intercept? What is the y-int on this one? What is it? 1,000. Right there. Okay? What does that point represent? Okay? So it wouldn't really be, we don't know, like, not the start of the flight, but kind of the start of the timing, I guess, right? So the original height of plane at 0 minutes. Okay, where does the graph intersect the horizontal axis? Okay, so at 10 minutes, right? What does that represent? Time it takes to descent. I think, oh yeah, it's DES, I think. You know, because descending has an S, and you'd think it would be, it's like decent, right? Throw a little English in there today, hey? You guys are gonna, too late. Too late. Did it. Can't take it back. Some things you just can't take back. Spurting a little English and math. It's done. Okay. What is the rate of change for the graph? AKA slope. Okay, come on, underline that, right? Slope. Okay, now the cool thing about slope is it doesn't matter where you draw your triangle. Doesn't matter. Okay, but what do we know about the slope? It should be negative, right? So you can go like this. Oops, probably not there. You'd want to go there. Or you could go like this. Doesn't matter. You will still get the same slope no matter where you draw that triangle. Okay? I'm going to improve it. Okay, let's do the big one. Would be what? Yeah, good. Negative 1,000 over 10, which equals negative 100. Okay? But say I didn't pick that one. Let's do the one that I did here. This little guy. What would be the rise, or the rise? Negative 3. No. Negative 3. Why would you say negative 3? Look at your side. Negative 300, right? Gotta look at your units. What's the run? Come on. We're going from 2 to 5, correct? Three, right? 1, 2, 3. Look. 1, 2, 3. Okay, so that one you would go negative 300 divided by 3, which is negative 100. Now what does that represent? But what is negative 100? What are the units for the negative 1,000? What are the units? Meters. The 10? Minutes. So that stays here. What does negative 100 meters per minute mean? Yeah? Good. So he is descending at 100 meters per minute. Now, do you see I didn't go negative? Because I've already said descending, right? So you could say he is ascending at negative 100 meters per minute. Okay? But do you see how descending says it's negative? Okay? So he's going down at 100 meters per minute. So whenever you do a slope, it actually has units that will tell you what's going on. Okay, it actually gives you a generalization of the graph. Okay, the x and y intercepts of the linear function 2x plus 7, then graph it. Now, I want you just to tell me something. At the y-axis, y-intercept, what is x? 0. Okay? So that's a little trick that I'm going to show you to find y-intercept, make x equals 0. Because x is always 0 at the y-intercept. Always, always, always. Okay? You show me a graph that where the xy cross, because that's all graphs, where the y-intercept x isn't 0. It doesn't exist. Okay? So, here is what I'm trying to say is I got f of x, which is the same thing as y, right? So if I said y equals negative 2x plus 7. Now, if I said if you want to find the y-intercept, make x equals 0, then we'll just go y equals negative 2 times 0 plus 7. So what's the y-intercept? Is 7. Okay, so let's go. 1, 2, 3, 4, 5, 6, 7. There's my y-intercept. And do you see that x is 0 at the y-intercept? So it's not like it's actually like a trick. It just makes sense. Like if you want to find the y-intercept, make x equals 0, because that's when the y-intercept always occurs. Okay, how about when you want to find the x-intercept? Let's be a little bit more specific. Do you see that the y-intercept, or the x-intercept, y will be equal 0? Okay, so how do we do that? Yeah, well, we'll have, because y equals negative 2x plus 7. So 0 equals negative 2x plus 7. Then what do I do? Subtract 7 to both sides. So negative 7 equals negative 2x. Divided by negative 2. 3.5 equals x. So we've got 1, 2, 3.5 is right there. That's my x int. Now if you know the x int and the y int, how many points does it take to make a line? 2. Do you need 3? 2 points is all you ever need. So if you ever need to draw a line, find your x-intercept and your y-intercept fast. And this will be your equation of your line. Okay, I'll prove it. Just because I feel like playing with my little calculator here. Okay. Negative 2x plus 7, zoom 6. Ta-da! And watch this. Trace 0 equals, see? When x equals 0, y equals 7. Okay? So, showing you what my y-intercept is and my x-intercept. Okay, so there's 2 new things that you need to know. Right? Again, is it a tough concept? No. But if you've never seen it before, it's a little confusing. Yeah, you got to make it more oval if that's, you know. It's weird to find out what people struggle with in life. We've all got problems, eh? Remember I knew this girl I knew in high school. She's like, you know, she's like the rich family, had the big pool and everything, and she said her life sucked because she always had to clean the pool. And I go, yeah, life sucks for you. Yeah, you have to clean your pool once in a while. But trust me, trust me, she was legitimately like, her life sucks, so she has to clean the pool. I'm like, I wish I had that problem. I have to clean the pool. But it's true. No matter who you are, you got problems. Okay? Yep. And better, unfortunately. Yeah. Blaine, you've already set down a motive. Okay. Now, each graph shows a temperature T degrees as the function of T, time, T hours for 2 locations. Determine the horizontal and vertical asymptotes, or intercepts. Asymptotes is coming next year, don't worry. And the domain and range, and the rate of change. Holy, lots to do. Okay, so what is the horizontal, aka x-intercept? Okay, so maybe you want to do this in a different colored pen, but this is your, because it looks a little weird, but that's your x-axis, or y-axis. This is your x-axis, right? So what would it be? No. What are you guys talking about, negative 5? 4. You need to look on the x. Okay? So 4 hours. What is the y-intercept, or the vertical intercept? Negative 5 what? Cows, chickens, potatoes, what? Negative 5 degrees Celsius. What is the domain of this? Okay, back to domain. Cole? Nope. It does not have arrows. Yes? Greater or equal to. Okay. Okay. Now I'm going to change this up a little bit, and I'm going to put t. Okay. Time. Actually, we're going to use, because we're going to use small t for time and big T for temperature. That'll mess with your heads a bit. Okay. So that's just getting it specific to the graph. Okay. It's good to mess with your guys' heads. There's got to be something good about this job. Okay, now, how about temperature? Big T is greater or equal to -5, less than or equal to 10. Rate of change, aka slope. Positive or negative? Okay, so we know we should be thinking that way. Now, it's rise over run, so you can do your rise over run wherever you want. I will tell you that the bigger the triangle, usually the less chance of error. Okay, you would think it would be more because it's bigger numbers, but no, it actually has less error. So I always just try and take and I build a right angle triangle from start to finish. Yes, you can do a little one, but you see how this one would suck, right? Because you're at a half a point there and stuff. So we want to just be kind of using the best. Now, what would be the rise? 15. Very good. Okay, what's the run? Okay, 0. I'm not getting 6. I'm getting 12. Look at your units here, guys. Right? Don't count the number of squares. It's not always the number of squares if their units are 5 every square. Right? You have to actually look at the scale. So it'd be positive 15 over 12. Okay? Now, that's positive 15 degrees Celsius over 12 hours. So what does that work out to be if you put it in your calculator? 1.25 degrees Celsius per hour. Can somebody tell me what that means? Okay, don't yell it out, but what does that mean? Like, yes? Connor? Good. Okay. So slope will actually give you your hourly rate, your how much you make every hour, that sort of thing. Okay? Now, this is location B. X-intercept. No. 5. So x-int is 5, right? Okay. Y-int. 10. Domain. So that's little t, right? Let's do that again. Little t, big T. No. T is greater or equal to 0. Less than or equal to 10. Okay, that's the way we want to write it. Okay. Range, big T, is greater or equal to -10. Less than or equal to 10. Okay, rate of change, aka slope. Okay, now, this is going to be the triangle I'm going to pick. So I always make a right angle triangle out of it. Now, if it was going on forever in both directions, I would make the right angle triangle that started and ended at nice points. Okay, so what is my rise? -20, because it is going down. My run. Okay, let's put units. -20 degrees Celsius. 10 minutes. So what is my slope? Yeah. Why do I have... Remember I was sick last year? Someone else put some different stuff in there. So, what would be the slope? -2 degrees Celsius per hour. Okay, so to translate that into English, the temperature fell 2 degrees Celsius every hour. Okay? So once you see this stuff, like that's the nice thing about this unit, it's just familiarizing you. The next unit we'll get into a little bit more specifics. But which graph has a rate of change of 1/2? Now it's a positive 1/2, so that should tell you right away. Should be B. And a vertical intercept of 6. Okay, that should be an insult to your intelligence, that question. That's not even worth getting up in the morning for that one. Now the graph shows the cost of publishing a school yearbook for Edmonton Christians High School. Okay, got to update that one. Ooh, okay, the budget for publishing costs is $4,200. What is the maximum number of books that can be printed? Okay, now here is a graph of number of yearbooks and the cost. What's the maximum that can be printed? Now, if you remember this, y equals mx plus b. What does this stand for? Now I'm really going to go back to 2 days ago. What does B stand for? Y-intercept. Always, always, always. Okay? So this is translating. This is actually getting information out of an equation. Now can we, without trying to make the equation, let's get it from the information. So what is the y-intercept on this? 500. What is the slope? Now we can do slope anywhere we want, but I'm going to do the biggest one that I can right there. Now what is my rise? So rise is 4,000. What is the run? Zero to 200. I'm not getting what you're getting. What is the run? 200. What's 4,000 divided? Now, what's the units? Rise would be $4,000 for 200 books, right? So what is my... That's $20 per book. So my equation is y equals 20x plus 500. That's the equation of that line. Okay, and I want to actually prove that to you. I'm going to put that equation in. So I'm going to go 20x plus 500. Now I want you to see something here. I'm going to hit the window because I want to have the same window settings as this. What is the y or the x minimum on this graph? 0. What is the maximum? 200. And what's the scale? Actually, it's kind of going by 25s, isn't it? Okay. What is the y minimum? 0. The maximum? 5,000, I would say, even though they didn't put the number up there. If I want it to look identical, I'll put that. And what is the scale? What is it? What are they counting by? 500. Okay, and then you just hit graph. Okay, so that is the graph of that. Now, the problem with this is it actually is a widescreen calculator, so it makes these quite small and this big, so it looks a little bit different that way. But if I put in, see this point here? What point is this? 1500. So if I just hit trace and I put in 50, okay, it is giving me 1500 as a point just like is on there. Okay, so I built an equation, or you guys built an equation. Okay, so, and as we get better, we're going to be building, next year you'll be building quadratic equations and cubic equations. Now, here's what I would love to see if anybody can figure out. Y equals 20x plus 500. Let's put this in context. What is the 20 and what's the 500? Okay, who's going to give me the 500 first? I want to know what that 500 is, yeah? The initial cost. If you bought, before you buy one yearbook, how much do you owe them? 500 bucks. That happens often. Yearbooks all the time. The more yearbooks people buy, it actually gets cheaper. Okay? Because if one person bought a yearbook, just one person, how much would it cost them? 520 bucks. I don't know if that's worth it. Okay, I'll take a few pictures with my phone. I'm good. Okay? Whenever you order t-shirts, they don't just print them off like, yeah, here's the, I mean, nowadays they can actually do it if you send away from companies like Cafe Press and stuff like that. You can get one t-shirt made. But you know, when you're doing silkscreen, they got to set it up. There's setup costs. They have to take all of your artwork and they have to digitize it, and they got to do this. So they're like, well, I'm not doing that for free. Okay, so it's going to be this cost, and if you order 500 t-shirts, I can give them to you for this much of t-shirt. If you order one, I mean, it's going to cost me 150 bucks just to set it up. So one, I won't do one. Okay, now they'll do laser stuff. They'll actually pull off one because they have that technology, right? But you can't do it cheaply unless you silkscreen. But this is your initial setup fee. It takes them a long time to make one yearbook. And then to print them, it's not a big deal for them. It's easy after that. And this is cost per book plus you have to pay for the initial setup fee. So do you see, if 500 people order a book, they're going to split that 500 and only have to pay a $1 each for that. Okay, so they'll pay their $20 for their book plus $1 for, so they can get a yearbook for 21 bucks. If you have 1,000 people, then it's $20.50 per person. Okay, so the more people that get it, the cheaper it is, right? Now, how many books to be 4,200? How many books can you buy? Now, what's 4,200 in this equation below? It's the y. So you'd go 4,200 equals 20x plus 500. How would you solve this? Subtract 500 on both sides. Okay, and you will get 3,700 equals 20x. Divide by 20, divide by 20. 185 equals n. Okay, so if they've got 4,200 bucks, we can get 185 yearbooks, right? And you know, nowadays you have to pre-order your yearbook. You have to prepay for them. So then when they put that order in, they know exactly what they're doing. Okay, I want to do just one more with you. So if you turn the page, I just want to do this linear graph. Similar, you actually have the same graph on your test today, your quiz, 2x plus 3. But this is the way I want to take it all in, and we're going to do graphing, domain, range, and the rate of change. Okay? Now, if you're given some points and you're given an equation, and let's not even use our calculator, we're just going to sub this in and get our y. So 2 times -8, -16. So I'll just do this one with us. 2 times -8 plus 3 equals what? -13. So -8, okay, now hopefully we can see everything here. I'm just going to highlight my x and y axis so you guys can see it, right? But We got, now, negative 13 is not even on here. Okay, so I'm not even going to graph that point right now. How about the next one? Negative 5. If you put 2 times negative 5, it's negative 10, plus 3, negative 7. So we got negative 5. Always do your x first. 1, 2, 3, 4, 5. And negative 7. 1, 2, 3, 4, 5, 6, 7. Okay, it's right there. Okay, what happens if you put 0 in? You get plus 3. What have I just found? The y-intercept. 0, 3, right there. Now how many points do you need to make a line? 2. But you know what I would recommend? Do 3 to make sure, because if that second point's wrong, you're going to draw your line wrong. But if you do 3 and you go there all nicely lined up, then you know you did the other points right. So let's do 5. 2 times 5 plus 3 is 13. So we got 5 comma 13, which again sucks, not on here either. But we should be why don't we put our own point in here? I don't like, because that's not even on my graph. Let's do 3. If I put in 3, I would get 9. So 3, 9. Okay, so you see how they're nicely in a line. Now, is this continuous or discrete data? Continuous. I can put any x in there I want. So that would be my line. And you see how it has arrows on both sides? Because that is true. It does go, don't go, oh, but you only give me negative 8 to 8. Okay? No, those are points to start drawing your graph. What's the domain of this graph? X is in the reals. Range? Y is in the reals. Now slope. Okay? Now I would use maybe this one here. This is what I'm going to use because it's 2 definite points, right? I'm just doing a triangle between 2 definite points. Now, it is going by ones, right? So what's my rise? So m equals rise over run equals 6 over 3, which equals 2. So the rate of change is 2. Okay? So that's kind of summarizing the whole unit. We did domain of range, we did fill in a table, we did graphing, we did slope. Yes?
If it gives you the equation and then asks for the slope, don't you just have to look?
Yeah, exactly. Now, that's kind of where I was going. So do you see how y equals 2x plus 3 makes sense? Was the slope 2? Was the y-intercept 3? Yeah. So do those checks for yourself, because as I come around, I'm looking at your quiz and I'm going, are you sure that's right? Right? Because you've got a different y-intercept on your graph, but if you looked at this, you'd go, it should be 3. Okay? Because is this always slope? Is this always y-intercept? Yeah. Okay? So here's another way you could have done this entire thing. So I'm just going to, this is the fastest way. If you give me the equation of a line, watch this. Okay? What is the y-intercept? So I do that. What is the slope? That means up 2 over 1, correct? So I go up 2 over 1, done. Okay, that's the fastest way to graph a line if you give me the equation. I do my y-intercept and I do my slope, up 2 over 1. Now I could have went up 4 over 2, that still equals 2. But the simplest, when they give me a slope, it's up 2 over 1, right? So this, you know how people hate fractions? They're much nicer when you're dealing, like if you gave me y equals 0.5, x plus 3, I don't like that. I like this, y equals 1/2 x plus 3, because what does that mean? Up 1, right 2. Okay? So this always means, so this number here up top is always up or down. So it's up, it'll be positive, down, negative. This number is always right. You always go right. Never go left. So you'll go up or down, depending on your sign, then right. So run is always right. You do. You don't want to run in the left direction. No, exactly. When it's a test and you're like, I remember what Shanna said. Okay. So this is what you're working on. So hopefully you're understanding this stuff, so we'll find that out.